So our next project is going to be presented by Daniel and Tingru. It was also built by Warren, but Warren unfortunately couldn't make it tonight. So as I said, he's going to be a bit of a floating head. So I hope you like looking at Warren's floating head and hearing him speak. So just bear with us on that, try and be engaged. I think it should be good, but this is also a really impressive project that is designed really well. We have two really good designers in this cohort that managed to build beautiful looking software. So I think you'll be impressed by this as well. Take it away, Daniel.
Oh, well. All right, guys. Welcome to Uplift. I'm going to guide you through the app we end up building after 2.5 months of development. It was built initially to give users a better insight on their financials. We do have a different approach. I'm going to start talking about our team. We'd love to talk about Warren, which is unfortunately not here. He was the main lead of the whole project, as well as the backend developer for it. Next off, we have Tingru. My partner is here, so I'm not alone by myself. She was in charge of the whole development of the front end, as well as the code leader, I will say. Myself, as the third one, Daniel. I run through the whole development process, as well as doing research and helping them both in the meantime as well. And lastly, we have Eche. He was more like the all-rounder tool that we had, because unfortunately for us, fortunately for him, he landed a job in WA, so that made it really hard for us to communicate and get along with the project. It all started from my own experience, actually. I often found myself asking, like, where's my money? What happened with my money? Of course, I knew I spent it, but, like, how did I spend my money? And then I came across with my banking app being a little bit overwhelming from time to time, found a lot of information. It is to be expected, right? Like, that's what you expect from your bank, to give you all the details. But that's not what we wanted. I wanted something more like visual, something more graphic, so I can clearly know where my money is going to. I also found that for you to get information from your bank account, it needs a lot of clicks. It needs a lot of navigation. That's pretty much it. And even when you have data, sometimes it's not organized the way you wanted to look at it, perhaps. So that's how it all started. All right, we came across in our search for a good and reliable source of data with our bank. It's an awesome API. That's why we choose them. It has everything we needed in order to develop and categorize the information we require for this whole application. They do have personal access token as well to cover the security issues as well. Real-time retrieval. And then it all came together with secure and reliable integration, right? So that's how Uplift came alive. We took everything got given by UpBank, and we built Uplift as an app to help you track down your expenses, give you financial insights, and most importantly, make it in a really easy way, like really graphical, and getting rid of all the navigation issues that I just mentioned before.
So what does Uplift do? Uplift provides users with a simple and organized view of their expenditures. It organizes spending by detailed categories like good life, home, personal, and transport. The one-click view allows easy navigation through the sidebar. Users get fast access to financial data with clear charts, such as donut chart for total expenses and bar charts for specific categories. These features simplify financial management, making it easy for users to stay on top of their finances. Now that we have an overview of what Uplift does, let's see it in action.
Hello, everyone. I'm a new user of Uplift. Recently, I realized I need to pay more attention to where my money goes. I heard about an app called Uplift that categorizes expenses. Curious about my financial health, I decided to give it a try. Let's start with the first page, Instructions. Step 1. I need an UpBank account. Click here, and it guides me to the UpBank website. Alright, I already have one. Step 2. Click here to get my personal access token. Okay, I've got one. Ready to go? Let's register. Now, I'm on the sign up page. Let's check the terms and conditions. Good. Now go back. I'll fill in all the fields, name, email, password, opt to receive the newsletter, agree to the terms and conditions, and click sign up. Registered successfully. Let's log in. Email, password, that's easy, and click sign in. Now I'm using my PAT. The instructions remind me again to get my personal access token, but I've got it, so I'll fill it in and click add PAT. Here is my dashboard. I can see my expenses in 4 categories: Good Life, Home, Personal, and Transport. I'll click on the refresh button and my expenses update instantly. Let's see in detail where my money has gone. Clicking on the sidebar, I see my profile at the top, followed by the dashboard and the 4 category options. Let's check out Good Life. All the subcategories are sorted by amount from most to least. It's obvious I've spent the most on TV, music, and streaming. Next, Transport. Oh, I didn't realize I spent that much on car insurance. Now Personal. Wait, I spent the most on hair and beauty. Finally, Home. Spending the most on utilities makes sense, but I didn't notice how much I spent on the internet. That's interesting. The last button on the sidebar is Sign Out. Now, as an existing user, I'll log in again, email and password, sign in, and add the PAT again. Alright, I'm logged in successfully. I see I can also contact the Uplift team via Facebook and Instagram, but not now, maybe next time.
I hope this demo video guided you through our app's key features, showing how easy it is to track expenses and gain financial insights with Uplift. Now let's dive into our design process. It was inspired by an approach called event modeling. Step 1. We made our goal clear: the user story of an app bank account holder who wants to visualize their category spends without any of the navigation or feature noise that turns them off most solutions in the market. Step 2. We brainstormed all events which must happen to fulfill that user's need. And Step 3. We ordered the events as a plot that unfolds the entire sequence from beginning to the end. Step 4. We embellished the slot with UI wireframes, visualizing the user's perspective and interactions. Step 5. We identified inputs and outputs, what commands the system to change, and what stored data must be read into a view.
And say welcome to Warren.
In the final step, we applied Conway's law to steer software quality. Conway's law is that system designs tend to mirror organizational structures. If that is a bit abstract, think of it like this. Without delegation and deliberate team structuring, system creation risks becoming overly conditioned by communication channels instead of preferred design qualities. Accordingly, we grouped events into areas of responsibility, such as expense and bank, ensuring that teamwork could operate along clear boundaries and promote decoupled software. Using the power of storytelling and specification by example, these design steps aligned front-end and back-end concerns and broke the system down into a set of autonomous parts that could be owned by individuals and reasoned about. In fact, a good design process was essential to our team because we were a melting pot of challenges and unknowns, changes of circumstance, crippled availabilities, and enduring personal crises had robbed us of team building and alignment opportunities. Would our values and interests harmonize? Would our team composition provide all required capabilities? Would we be able to handle upstream and downstream dependencies, parallel development, and technology integrations? Yes. Yes, because we used the power of storytelling and specification by example to create a design that inspired action, was easily checked for completeness, and clearly communicated back-end and front-end workings.
So we created a sequence of screens to represent the user journey. First-time user starts with an onboarding process, including sign up, login, and adding their personal access tokens. This process is intuitive and guides users step by step. After setup, they access the dashboard for a summary of their expenses. Existing users log in, add their PATs, and see a personalized dashboard with their financial summary. The sidebar allows quick navigation to detailed expense views. As a front-end developer, I focused on creating an intuitive, user-friendly interface with a clean layout, easy navigation, and visually appealing charts. The design enhances readability and provides a pleasant user experience.
You have seen the front-end outcomes of the design process. What were the software outcomes for the back-end? Based on the areas of responsibility identified in the design process, we implemented a highly decoupled microservices architecture. A user's entry point to the system is the front-end service. As they click buttons and view web pages, the back-end for front-end service coordinates the activity of all the other services that play a role in fulfilling the needs of the user. Each of the services you see are specialized with the capability they provide. Although they can interact over HTTP, they are fundamentally autonomous. They persist and control their own data, deploy separately, and run in their own processes. For example, the bank service knows how to retrieve and store historical and real-time activity straight from Up's public API into a document database. But the expense service, which is sent bank service data, is individually deployed with its own relational database. Independently, it stores, enriches, and manipulates data structures to provide capabilities focused on expense tracking, not bank synchronization and retrieval. There is extra complexity and more attack surfaces in this architecture, but there are benefits too, either straight off the shelf or when specific patterns are applied: fault tolerance, scalability, reduced technical debt, decoupling, and cohesion. Architecturally, the services are decoupled at the application level by the mediation of RESTful APIs, but there is also service-level decoupling. Internally, each service has an API layer, a business layer, and a data layer. In this three-layer architecture for the services, the business layer has only one reason to change: if the goals or rules governing the service's capabilities change. The web API controller could be replaced with a command line controller, or the data persistence layer could change technologies, perhaps introducing distinct read and write models for performance optimization. Regardless, the business layer would not need to change. Instead, the business layer provides abstract ports the other layers must implement and adapt to. There will be no extraneous bleed-in because the business logic is insulated. This makes it easier to navigate separate concerns and audit code logic through the layers. It also becomes easier to connect business logic to changing usability, integration, and performance requirements. Our services can evolve painlessly. Within the backend, security is handled by the client credentials flow. Each service has middleware that will subject any HTTP request to a security test. If the request contains a valid access token, it is authorized. If it doesn't, it is rejected. These security concerns are encapsulated into a software development kit that each service privately maintains. Then, trusted microservices can install the SDK client and use well-named functions to make authorized calls to its respective service without exposing low-level details.
So, tech stack. Our tech stack is a blend of front-end and back-end technologies for seamless user experience. On the front end, we use React for dynamic UIs, Material UI for responsive design, and Recharge for interactive data visualizations. SWR and Axios manage state and data fetching, while our UI designs are crafted in Figma. On the backend, we use Fast API for high-performance APIs, SQL Alchemy and Alembic for database interactions and migrations, and MongoDB for document storage. YAML and Toml handle configurations. Docker and Docker Compose manage containerized applications. PyTest is used for testing, Faker for generating test data, and Makefile for task automation.
I didn't think about this, but the way we collaborate involves a lot of creativity, as you might notice with a virtual Warren friend. While we were doing the coding and the development problem in general, we rely on Slack. I think we never give it a thought about changing it. It worked for us. So at least we try to run daily meetings for half an hour, sometimes less, sometimes a bit more. We did a bit of troubleshooting, kind of peer review when needed, or just to give somebody else a hand as well as required. Then we relied on Figma to create some sort of demos code where we have what we're working on out of that list, what's required, that must be, what should be fixed, something that is not really necessary but it'll be good to have, and other stuff. Having that gave us a really good focus on what we should prioritize, and we also could leave notes over there and see how we were doing and whether we have issues or not. Or, like sometimes we just went there and leave feedback for the other one, like something like, I don't think the way you're doing it is okay, try this. Or perhaps we could do it the other way. But yeah, basically we rely on Slack and Figma throughout the whole development process.
Yes, and about the challenges faced about front-end. As a front-end developer, I faced several challenges. Error handling was a major one, ensuring that error messages for invalid emails, passwords, and expired PATs were clear and helpful. We aim to guide users on correcting their inputs. Content design was another challenge. We focused on creating an intuitive user experience, guiding users step by step through onboarding and navigation with clear and visually appealing designs.
Challenges faces on the backend. I'm not 100% sure. As I mentioned in the beginning, Warren was pretty much in charge of all the backend. However, I do know we struggle a lot with the microservice. We came with the conclusion that they're really good for medium to large size projects. For small ones, although they work really good, it might be an extra difficulty that you can avoid. I couldn't run it on my end, although Tingru and Warren did. We also have a lot of issues translating our design process, which was based on events, to non-events like regular code, as we couldn't find like a reliable way to code based on events rather than the regular way of coding. Yeah, I think that's the main ones.
So, about the reflections, here are the key lessons we learned. First, learning by making mistakes helped us understand the enduring why, not just the current what. Mastering our code in an era of AI-generated and publicity-sourced content is crucial. And we also emphasized progress over perfection to combat perfectionism and maintain momentum. Finally, we recognize the importance of inclusivity in small teams, valuing diverse perspectives and fostering collaboration. These reflections highlight our growth and learning while developing Uplift.
Then last but not least, thank you all for sticking around. I would love to thank, of course, Canva for hosting us. I also want to give a shout out to Brandon Grenier for his valuable insight in the backend development, all the Holberton team, and of course all of peers, not only for the final project, but like throughout these 9 months that we've been all working together, and we've been pretty much throughout the same process. And it's been pretty cool sharing with you guys, giving you a hand as well as asking for help when required. Yeah, thank you.
Yay, round of applause.